Hello everyone, my name is Ravinder Katla, and first of all, thank you for giving an opportunity to introduce myself and then conference opportunity. So if you have any questions regarding this topic, you can reach out to me over the email or and LinkedIn. So today I'm going to discuss in this conference is the evaluation of any enhanced automotive infotainment system. And as well as I'm going to discuss the technical innovations and then future prospects. So let's start with some basic things. So, you are automotive infotainment. Automotive infotainment is information plus entertainment is infotainment. When you sit in a car, you see the display in front of your driving seat, camera in front of you in the console. And that is the infotainment system. It isn't the sound for the entertain the things like you could do the video games in a parking in a park mode. And then as well as you can do vehicle operations like change the settings. That is the infotainment systems. Hope you all knew that. But just wanted to in brief overview. But in this topic, I am going to discuss how the AI is influential interacting with the automotive infotainment system. So in this conference, I'm going to discuss the technical framework and challenges and as well as the breakthrough solutions in the development of AI-powered automotive infotainment systems. So let's start with some basic things like the market growth and technological evolutions. So if you see this, there are the 21.63 billion revenue from infotainment. So that will be projected at 37.6 billion by 2023. AI enhanced system, which is currently accounted for like around 42.3 of the market. That is expected to dominate, dominate the future growth, future automotive industry. For the AI, but the basic thing is voice recognition because of you need to talk to the entertainment system. That is the easiest and more fastest way to communicate into your entertainment system. So in 2020, the voice accuracy it used to be like an 82.4%. Around 20 voice commands, almost three or two operation like voice commands got failed, unable to process that command. But in 2023, that increased to 96.2. Right now, it's almost 99.99% accuracy of the of your voice commands. And then the other thing is the fast response. The responses are so very reduced. Right now, it's 2.7 seconds to whenever you are asking to the infotainment system, it will respond like that. And then there are so many things involved when you get into that things. First of all, computational architecture evolution. So in 2020 and 2018, you start with the 2018. So we used to, or like automotive industries use 1 to 2 processing units. We call them vehicle interface processor. The vehicle is consisting of ECUs, electronic control units. Each ECU consisting of specific set of operations, PCM, body control modules, specifically designed for braking system or lighting, some of the most critical operation. And then there are lightning module, especially for lightning system. And then there are the vehicle control units, and then as well as the audio amplifier firm modules. Firm modules are like audio systems. Those kind of things are there. It's consisting of the auto vehicle is consisting of number of ECs. So in 2018, it used to be 1 to 2 processing units, but 2020 it is 2 to 4 processing units. More demand, more capabilities are introduced, and then 2023 and 2022. It was like 5 to 8 processing units. So imagine 5 to 8 is 1 trillion operations per second. Now whatever the 5 to 8 processing units, it will operate on trillion operations. And right now we are almost to triple here that 3 trillion operations per second. That's how we increase the capabilities of the operations, and then low power consumption. That is also another thing we need to consider. Automotive is first priority is safety. Safety is when you are driving a car. Safety is the first priority for the automotive industry. That's right. Every automotive industry implementing any capabilities or anything, the safety is the first priority for their operations. So that's how they operate it. So let's get into that driver monitoring and personalization things. The AI is also uses not only for your voice recognition but also camera. So how you are, whether you are sad, whether you are sick, whether based on your eye movements, based on your facial expressions, it will recognize and then say, based on your command. If you are dull, if you got into a trouble or anything, it automatically get directly connected to your got an accident, any need anything, any sudden movements, it automatically directly connected to the back office system and directly connected to your 911 to get help as possible, and then call your insurance. That's how this AI is added those capabilities, and as well as the adjust your information, your personal information, whether it's you save locally, save in the back office, but it needs to be private. No need to be shared with someone. So that is also a priority for the AI. And then there is an neural networks that is like analyzing multiple inputs. You are driving same location multiple times, and then AI recognize that one and then determines, okay, you are going to this one, you are going to this route, and then is there any traffic in that location, and then it will give an input like suggestions. Oh, hey, you are going into this direction. We have some trouble. We have closed some roads or something like that. So then you have a better things and a better state in your day. So that's how your time is saved, and then you can safety of you are driving. Safety is also considered, and then as well as the driver attention when you are driving. Suddenly traffic behind you or something, then it will recognize and then think, okay, hey, there is traffic. Did we it? Then that's how things are working. So let's predicting AI and context awareness. There are four things we need to be considered: temporal analysis, and then geo-pattern intelligence, and then behavioral pattern recognition and feedback or prediction. They are designed for a different things, like day after week or pattern recognition. When you are a particular day, you are doing something, you are about to do something, and AI predict that one and give the suggestions. And then there is another thing, like you are about to, you are a electrical vehicle, your charging station, recommended charging stations. It will give an recommended charging station, and then audio setting based on your mood. You can you will give an alert. Hey, I'm going to set up this song for you. You agree or disagree? It's up to you, but yeah, it will give an suggestion. And then behavioral pattern based on your mood, based on your preference, based on your media preference. It will give a name, and like okay, I'm playing this song, and looking okay, I want to play this song. Yes or no? Yes, it will play. Then without much thinking of it automatically recognize your mood, and then feedback loop. That is another thing. When the AI given a suggestion, but you don't like, it's okay. It will why it is rejected. It will analyze the AI, and then next time don't repeat that mistakes. That's how it helps. This AI is. And then resource constraint and optimization. In automotive industry, so there are hardware limitation, and then power efficiency requirements, and memory management, and safety critical operation. So these are the main constraints for advancement. Right now, hardware limitations, that like one of the core hardware in automotive industry It used to be $1,200, but now it's almost $3,000 to $5,000 per unit. So that's and then the budget is also very important for the vehicle license. That these restrictions are for you need to be small. The electronic control unit ECU is must be small, and as well as the doing the more operation, trillions and trillions of operation. And then second thing is battery efficiency. That in automotive industry, any range is a question. For hey, my company is doing 650 miles per hour full charge. Hey, my EV is like 300 miles per full charge within 15 minutes. Something like that. Power efficiency is the thing we need to consider. And then memory management. Then, so how many operations we are performing to the users, and then we need to store. You need to store and then use those information and then give to the right feedback, right information to the user. And then there is a safety critical operation. That is one of the performance guarantees. Oh, hey, my automotive industry is doing good with these operations, something like that. So that's how it's working. And then there are privacy and data management. This is another thing. So privacy is the main important for our automotive industry when you are introducing into the automotive industry, because of you share your personal data, you shared your things to your car, and that needs to be stored somewhere personal. That's how. And then there are different things we need to consider as an automotive engineer. First thing is on-device processing. Only sensitive data are stored in locally, like in here. And then the remaining things are like stored in cloud services, and then privacy exposure to the remaining vendors. And then under difference in privacy, and then and transmission and mathematically guaranteed individual privacy while maintaining the statistical usefulness documents. And these are the things. And then the federated learning that distributes model training across the vehicle, keep the raw data and local, allowing the fleet-wide AI operations without centralizing the personal data. So time-limited storage. Hey, I'm going to store this data like 1-2 months, something like that. When you change the owner, it automatically delete your data, delete your personal data, and then keep the vacancy without any personal data. That's how privacy we are going to introduce into the automotive systems. And then safety. As I mentioned before, automotive is first thing is the safety and distraction mitigation. So safety is the first priority whenever we are implementing anything. Safety is the first priority. So what are the mitigations we are going to? First thing is workload adaptive interfaces. When the UI elements may standardizing complexity, reducing the computing load by 43% during hiding driving situations. And then multi-modal interaction design, whether you are using voice, touch, or get anything, to be to be distracted when driving. That is another thing. There are a couple of things we need to consider. Driver must be concentration on the road without doing any further operation. Hey, touching some infotainment system. No, you're not doing that. Because of safety is the first priority. And then attention and aware interruption. If you are talking to the AI, that's okay. If you are not concentrating on your driving things, then that's the interruption comes into the picture. And then we can notify the driver, hey, you need to be eyes on you, eyes on the roads. That's how different things, mitigation, we are going to implement into that safety and structure, mitigation things. And then the further thing is testing and validation methodology. How the testing is conducted. So first thing is doing some basic testing. The national highway and the traffic safety, the administration, whatever the guidelines they provided, we do that some basic things. and as well as some of the mentioned principal verifications, and then brand specific interaction standards, and then there is a controlled environment testing. We have tested like only certain things, and then certain behavioral analysis, and then certain task we need to give to the infotainment system, and then perform to observe the, and then further we are going to develop the driving simulator validation. But if just in-house driving, but you are giving all the feedback to the AI, and then how the reaction time, and then how it is working, and then the fourth phase is real world validation. We have any certain drivers, we will give the vehicles to the owners. We call them test fleet owners, test fleet vehicles, and then owners will give an all complex instruction to the AI, and then how the AI is interacted with that things, and then we can modify, and then we can rectify those things, and then we can improve our AI into the infotainment system. And then future directions and technical roadmap. So in the future, there are things need to be considered in our AI. So first thing is multi-modal deep learning, integration of vision, audio, and sensor data, and unified AI models. And then autonomous integration. So when you are driving hands-off driving, so you don't need to be looking into the road or some. Fully autonomous, you don't need to be, but semi-autonomous, yes, you need to be. Sometimes you don't need to be hands on the wheel, like autonomous. But in that state, we need to be interacted with that AI to that autonomous interaction. So we have a better autonomous system, and then AI, augmented reality integration. So that is another thing. Like in the windshield, we can show, hey, this is the information. This is the weather. This is the speed you are. This is the traffic you are going to in 15 minutes or 10 minutes, something like that. And then emotionally, based on your mood, based on your emotional state, driver, he given advice and responded according to your moods. And then V2X, vehicle to everything communication. We do vehicle to network, vehicle to charging area, vehicle to interface. So this kind of communication is vehicle to another vehicle to vehicle is also another communication. So how that things are, we need to looking into that. So this is how AI we will use into that automotive industry, and then we will focus more on the deep learning models, and as well as the how AI is interacted with an infotainment system, and then as well as the autonomous integration into the infotainment system, we achieve a better and bright automotive systems. Thank you so much, and thank you.